Grade 11's, the next CAM activity refers to a scenario where the municipality has introduced a water restriction process. Because of the continuous drought in the area, the engineer was given a brief to design a mechanism that would gradually open and then gradually close the main outlet valve to the town's reservoir automatically. The engineer, which is you, applied the principle of a CAM to solve the problem. So that is our given scenario. Read it again just to give some background to the CAM which we are going to be drawing. So what has been given to you in this particular activity is a CAM shaft, which is going to be this circle that you see here, which I'm coloring in. The CAM shaft has a diameter of 16 millimeters. And then also you have that CAM shaft which will rotate in a clockwise direction, and the arrow is given there in a clockwise direction, and the follower, which is this component here, which is new to our CAM displacement and CAM profile. So that follower has been given, and that follower is 8 millimeters in thickness from the center line, 4 millimeters and 4 millimeters both sides of the center line, which we are going to draw. And it tells you the length of it, which you have to calculate from the distances given. Alright, so we are going to draw the CAM displacement diagram in this space over here, and then we are going to draw the CAM profile in this space over here. So it is very important that you have good space organization on your page. Do not start in the middle, you have to draw the CAM displacement diagram here. So in this case we are not working with degrees, but we are working with hours. So we are going to label the bottom of our CAM displacement diagram as hours and not degrees. Okay, let's start. Firstly, I'm going to copy all of this information in this space over here. So I'm simply going to take my set square and draw a line faintly like that, and then I'm going to draw another line here, which is going to be my crossing, which is going to be that crossing which I have right there. Around that crossing I am going to draw a diameter of 16. So basically you can use your compass or you can use your circle template. My compass will use a radius of 8 millimeters, right? 8 millimeters like that, and then I will draw a small circle, which is going to be very difficult. Alternatively, I can just use a diameter of 16, which I will find on my circle template right here. So there's my 16, and I'm going to make sure that I draw my CAM profile or my CAM shaft. I'm going to make sure that I draw my CAM shaft right there around that center point which I have there. What I like to do, because it's my CAM shaft, I'm going to highlight that by hatching it like that. That is my CAM shaft that I have there. So now I'm going to draw my follower above the CAM shaft. So I look at my dimensions, and from the center I need to go 24 up. So there I've got 24, and I mark it off at 0. And then from the center point again, I'm going to have the height of my follower, which is 89 from here, 89 up, and 89 is one short of 90, which is going to be there. All I'm going to do is I'm going to draw my wedge ended follower, which is going to be at 60 degrees from the bottom point. So there I've got a 60 degrees like that, and there I've got a 60 degrees, and that is going to be my top part over there. This is my center, which I have here, and I'm going to measure 4 off the center because it is 8 millimeters. And to get it perfectly 8 off my center, I'm going to go 4 millimeters and 4 millimeters here. and there I am going to draw my cam follower like that. I will use my 60 degrees just to darken that part there, and my 60 degrees to darken that part over there, and of course my top as well. Here we go. Right, then the area between my center of my cam shaft and the tip of my cam follower, that is going to be my minimum radius. I am, however, going to take my compass, anchor it in the center there, open it up at the bottom of that cam wedge follower, and then I'm going to draw a circle like that there, and that basically would be my minimum radius. And inside my minimum radius, I'm also going to add my arrow, which is going to be in a clockwise direction there. Like I have it here in my instructions. And then of course the tip always forms my base of my cam displacement diagram, or the circle which I have there, which is in the same line, forms the base of my cam displacement diagram. Now I'm going to draw a starting line or a finishing line at the back there, and because we are busy with hours, I'm going to make that 12 hours. If it was degrees, it would have been 360. Okay, now we have to look at our cam displacement diagram information right here at the bottom where it states instructions. Let's read what it says. You need to copy the cam shaft and copy the cam follower detail and the direction of the rotation, which we've done already. We have to convert the motion of the follower into a graph, and you need to use a horizontal scale where 1 hour equals to 5 millimeters and the vertical scale of 1:1. The vertical scale will always remain 1:1. We're going to use 1 hour that equals to 5 millimeters, and there's going to be 12 hours, so we are literally going to measure 5 millimeters away every time. And if you say 5 times 12, it's going to give you 60, so I'm going to place that perfectly there at 60 there, and just have my 5 millimeter spacings like that there, perfectly apart. And you can count it afterwards and ensure that the amount of spacing that we have is in fact 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm going to project my lines up, and I'm going to suggest you do that as well. I've projected my lines up, faintly of course, and now I'm going to label it, and I'm going to start at 0, 1, 2, and I'm going to carry on right till 12. Let's do that quickly. We are going to go to our bulleted section of the specifications now, and we're going to follow through by drawing our cam displacement diagram. It states clearly that the cam rotates once every 12 hours, transferring uniform motion, that word uniform again, which means straight lines, to a follower that reciprocates, and reciprocate means it moves on a vertical line, which is this line over here, and it passes through the center of the shaft. The motion over the 12-hour period is as follows. From 24 hours, which is 12 o'clock, till 4, the outlet remains closed. So closed means there is literally no movement. So 12 hours is also similar as 0 on your clock. So from here, 1, 2, 3 until 4, there is going to be no movement. So I'm going to draw a solid line right there from 0 to 4. 1, 2, 3, 4. That's going to be our first movement. Then it says from 4 o'clock to 8 o'clock, which is another 4. The outlet opens at a uniform speed until the follower reaches a maximum height of 57 above its closed position. So from its closed position, on another 4, which is going to land up at 8. So on 8 we're going to go 57. And I'm going to measure 57 perfectly on 8. And there it's going to be. So I'm going to draw a line from there until I get to that specific point of 57. And then I go to my next bullet. It says here that from 8 o'clock, where we are now, to 10 o'clock, which is 2 hours after that, the outlet remains fully open. So open is going to be just going straight like that. There's no movement at all. And then the last bulleted point states from 10 o'clock to 12 o'clock, the outlet closes at a uniform speed. So it comes down right to its origin from there. Okay, and there we have concluded the cam displacement diagram. So it's very important to print your cam displacement diagram and the scale below that as well. Let's do that quickly as we finish off this drawing. So there I've labeled that very clearly, cam displacement graph, the scale of 1 hour equals to 5 millimeters. The second part of my cam would be for me to set up the cam profile, and I'm going to draw my cross here and my divisions first, and then I'm going to draw my outside or maximum radius here, label it opposite to the arrow, and then of course I will take each of these specific points here, mark it clearly like that, and then transfer it onto my center line, and then transfer that onto the respective number that's corresponding with the hours that I have here. Let's do that quickly, and please pay attention clearly to how it's done. there we have completed both the cam displacement graph with a scale of 1 hour is to 5 millimeters, and projecting this over to my rotary motion of my cam profile, causing this shape to be formed from that uniform motion that we have there.